Alright, welcome back, and in this particular video we're going to focus on using the t-test as well as assessing normality and understanding why normality assessment is important. So if we're comparing two groups, t-testing is probably the most common option. You'll occasionally hear about z-testing, and they covered a lot in stat classes, but you'll see the t-test or the t-distributions used far more often for assessing continuous data, and non-parametric methods exist, and you may hear about tests like Kruskal-Wallis or Mann-Whitney type tests, and we'll get to those with other stat programs. Excel does not necessarily lend itself to working with them, but t-testing is more appropriate when the data are normally distributed. So when data do not fit the bell curve or have a non-parametric shape, then we would probably consider non-parametric methods. So t-testing generally should not be done if the data do not fit the normal distribution or there's strong distortions from normal with regards to any of the continuous predictors. Now, I'm talking about continuous predictors. I'm talking about things that are like numbers that may range anywhere from negative numbers all the way up to very high positive numbers, but we could be talking about things like age or income. Those are not necessarily categorical. Age could be 21, 35, 46. Categorical variables generally are things that you might code as like 0 or 1, or coded as 1, 2, 3, or 4. So continuous variables versus categorical variables are treated differently in statistics. And continuous data should be evaluated for whether or not they have a bell curve type distribution if you're going to be using normal statistics, including t-testing. So if you are not using data that are normal, you may use the rankings. So you'll see that the non-parametric methods use ranks. So rather than actually using the true numbers, the numbers are ranked from lowest to highest, and the ranks of two groups are compared. The data may also be able to be log transformed, where you don't necessarily do your analysis based upon the actual values like income, but you may use the log 10 or even the natural log values. So you change the scale in which the continuous variables are being studied. So there are ways of assessing whether or not our variables are acting normal. But before you do that, one big problem with Microsoft Excel, based off of that categorical grouping that we did in the previous assignment, was we may not have checked for missing data. So we're going to want to check for missing data, because when you do the sort in the groups 1 and 0, you might have an issue. So I can show you that here when we open up the Excel table here in a second. So we'll check for missing data first. So I'll come back to that. So t-testing and non-parametric stats, that's what we're going to focus on really quickly here. So how do we assess normality? Before we can do our t-testing that we want to do, shouldn't we at least see if t-testing is something that's appropriate? So we might want to compare two groups. So this is our typical bell curve. So the mean, median, and mode for our age, the most commonly observed age value, also our middle value if we were to rank them from lowest to highest, which would be our median, and our mean would all be about the same. So all three of those things coming together would be indicative of probably a bell curve, but then there should be a gradual, departure on both sides of it to have this bell curve. If the departure is steeper on one side or more gradual on another, then there's a skew there. The opposite's possible over there. So we can have other types of shapes other than just skewed shapes. You may have shapes where you've got a bimodal distribution, where the median may actually be the same, but the mean may not necessarily be. Or you can have something where the mean and the median are the same, and unless you do a histogram, you may not see this. So Excel does not allow us to do the normality curve assessment as easily as a stat program, but there are three ways we can deal with it. We can use bar charts or histogram plots. We can look at skewness and kurtosis. Skewness and kurtosis are the two easiest ones with Excel. They're not ideal by themselves, but they do work. So again, why are we doing this? Well, we want to do our t-test on data that are behaving normally. And age and income tend to not do so, but people often still use t-testing and they may be grossly violating normal assumptions. So how do we assess normality and look at our data? Well, we can use the histogram function. But in order to do the histogram function, the data, we have to define the bins. It doesn't automatically create the histogram, which we would love to have done. So I'm going to just show you a comparison here in a second. So we also have to highlight the data and then put the bins category also being highlighted. And then we have to also tell it to turn on the chart. So there's a lot of little steps that we have to do. So we're going to go ahead and do that really quick. So let's open up Microsoft Excel. So I'm going to open up Excel here, and let's pull up my Excel file. I'm going to pull it over here. All right, here's Microsoft Excel. Now I've got two columns of data here. One of the things I told you to do is we want to, and this is this is tedious, and keeping track of all these little things you have to do make this more error prone rather than coding type things. So there's more manual manipulation going on. So one of the things we were looking at was ever used e-cigarettes. So they're all coded as 1 there. So all these people are all good. They're all coded as 1. Now, when I did the sort over here, ever e-cigarette, I've got people in this group that's e-cigarette 30 days. When I got over here, this particular group, there are people who we never got an answer from in the survey. They didn't answer that question. So how do we handle that? We don't want them to be average because we don't know. They may have had a smoke or not, or they may have vaped or not. That was the question. Have they vaped or not in the last, or ever? So one thing we could do is we can, I can change this color here, and I'm gonna maybe go in and just manually copy them. Maybe we don't want to totally delete the data forever, but we need to put them somewhere. So I'm going to put them all up here, all by themselves. So there they are. If I want to put the headings over them, I can, I guess. It's not necessary. We're not going to be working with them. But we didn't delete them. The information on these people, it's still there. But something's goofy with the survey numbers or something. Maybe the survey number is set up on a code. Yeah, something's goofy with how that survey number got brought in. I don't know. Okay, I probably didn't highlight everything that I needed to highlight. So let's get all those, redo this. It's a real pain dealing with all this data manipulation. You'll find out that if you do any statistics, dealing with getting your data ready for analysis can sometimes be the most unsatisfactory part of your exercise. So getting the data collected in a way that makes it easy to use when it comes time to analyze is very helpful on the front end. So I've got that information up here. So we've saved this missing information. We would probably never, I don't need it, but it's there. It's a good practice to have. So now we've cut them out of here. They're no longer part of this. So when we do our descriptive stats, we're not including, you know, this missing information down here. All right, so now into the actual histogram. So one of the things about Microsoft Excel that presents a real pain is that it does not automatically do the histogram that we would like. So we actually have this option here for histogram, and when we do the histogram, we have to highlight whichever column that we want to compare. So we're wanting to look at whether or not there's a difference in the average age among people who have ever used e-cigarettes or not. So we have a continuous variable here, which is age, so we need to assess it for normality to make sure that a t-test is acceptable. So when we do this, I can click on age, but then I have to tell it, if I don't have a bin range here, if I don't tell it the bins, if I don't create this column and this doesn't exist, it doesn't work. So I'm going to get rid of these. I just created these. What's the appropriate range to create? I'm going to cancel this, so I'm going to delete this for now. So what's the appropriate range? So you don't have that. You know, I don't know. You know, that's determining this. Usually a lot of softwares do it much more quickly. So here I've got another stat program. This is Stata and Data Editor, and you can see that it operates kind of like a spreadsheet. But I can use a by command. So first I have to sort the data by age, or sort it by whatever I'm looking at, ever used e-cigarette. And then I can say by ever used e-cigarette sum age, and then it gives me everything I need. The means are right there. If I want to do a histogram for this, I can tell it to produce the histogram for me. It also does point and click, so you can also do, you know, the classical, we've got a variety of distributional plots. There's all kinds of different ways to do these. So we'll look at one here in a second. All right, so I can just type in histogram age, and that's everybody unsorted, or I can actually tell it to do by our variable ever use e-cigarettes histogram age. Well, it doesn't allow us to do it, so there's a way to get it to do it. Okay, so I'm going to tell it histogram age and then do it by ever e-cigarette, and it presents these two histograms. Obviously they don't look anything like a bell curve because our age variable is pretty heavily skewed. So it's very simple to do that with a stat program. When we do this with R, you'll be able to see that as well. So in Microsoft Excel, when we want to use this as an option here, I have to have my tools turned on. I have to have the data separated into the columns like we've already done. So we've got the age of this group here versus the age of this group here. So we're going to have to generate two histograms manually. So we have to go to data, and then I have to have our tools, data analysis, and then I have to tell it the histogram. But when I do that, it makes me put in these bins. And I don't know, again, what bins to actually make, so I actually physically have to create a column called bins, and then I'm going to just set these at like 16, you know, or we'll do 17, 19, 21, 23, 25, and you know, we'll just leave it at that. Or actually, we'll throw another one in there, 27. And then anything over those, it should know how to handle. So data, all right, or tools, data analysis. Now I have to tell it to do the histogram. All right, which group? I want to do this group. In the bin range, I have to then highlight the bins. I highlight the whole thing because I've got the labels box checked. So I have to have a column title, and then I tell it to run. And if I didn't have the chart button turned on already, you have to turn it on. So again, this does not look like a bell curve. We've got a lot of people up there on that left end. All right, so that's the histogram for the one group. Which group is it? I have to go back over here to another. A lot of pointing and clicking involved in this. You know, sorry about that, but that's the nature of how Excel works. So with regards to age, the histogram you viewed was for the ever used e-cigarette group being 0. So they've never used e-cigarettes. So that was that group. So you can look at the histogram for it. There it is. Most of the people are still 19. We got about this group here, 21. All right. So that's that histogram. Back to the table. We're going to do the histogram again, but this time, Tools, Data Analysis, Histogram. We're going to go over, but instead of using this particular group, I have to go over and find this group. Age. There we go. I've got the labels checked. The bins should still be the same. So I can click on that. Alright, they're the same bins that I've artificially created. A lot of stat programs will just do that for you. It'll set the bins. So there you go. That's the histogram creation. So I'm going to stop the video here. Doing the skewness and kurtosis is much easier. And we'll go to those next. So before we close though, it's important to realize there is no bell curve here. So this would tell you that using a t-test probably would not be the most appropriate method. We'll get to that later. All right, so that's all.